Alright. Let's do a inference about two means of independent samples. Before we get cranking on that, let's look at on dependent samples I used mu sub d equals 0. On this one, I'm not gonna state the null hypothesis like that. I'm gonna state it as mu sub 1 equal mu sub 2. And the way I'm using it, they're interchangeable. Because mu sub d equals, or in the previous problem I did, mu sub 2 minus mu sub 1 equals mu sub d equals 0. So just saying that the difference between the two is nothing, which is the same thing we're saying here, which is the same thing we're saying here. So I'm going to use this as my two hypotheses for this equation. Just wanted to say it out loud in case anybody was confused, or in case anyone was going to be confused. So I don't know if I explained well enough about dependent and independent samples. I'm getting these out of the book under the categories, and I'm doing them appropriately. Whether I'm explaining why they're independent or dependent properly, that's debatable. So we'll just take my word for it that these are independent samples, and the ones I said were dependent were dependent. You got nothing else to go on. So our H naught is going to be mu sub 1 equal mu sub 2. H sub 1 is going to be mu sub 1 does not equal mu sub 2. My coffee's ready. This is the claim. And we're going to do this at alpha level of 0.05. Now, the book gives me some stats. We're going to do stats instead of data this time because I said so. So we're going to we'll do just group 1 and group 2. And we got mean speed, we got standard deviation, and we got sample sizes. So the numbers we're using are 260, 53, and 35 for group 1. For group 2, we got 269, 34, and this was also n is 35. The way the question was worded in the book was, do people arriving at the airport, which we'll call group 1, do they walk faster through the terminal than people who are departing from the airport, which is group 2? So X bar is going to be the mean speed of the person walking. I think it's feet per second. Feet per minute, that'd be pretty quick, wouldn't it? So mean speed of feet per minute, standard deviation of feet per minute, or of the differences in between the pieces of data. And then 35 is the sample size for both categories, just to give you a little background on the question. Anyway, so we'll use these numbers and we'll call them x bar sub 1, x bar sub 2, s sub x. I'm just going to write s sub 1, s sub 2, m sub 1, n sub 2. So we got 260, 269, 53, 34, 35, and 35. Alright. So, because the sample sizes are the same for both groups, you can kind of make a decent guess. Since the sample mean times aren't the same, you can assume that H sub 1 is going to be supported due to this evidence. But despite their inability to write a question that you can't answer without solving through the equations, we're going to work it anyway. Alright, so we have an equation to find our test statistic. It's not a fun equation, but it's an equation nonetheless. So everybody just remember that H sub 1 is clean. And most of the time it is. If it's not, it's rare. So we got, this is going to use the t-tables. So T naught equals x bar sub 1 minus x bar sub 2. I'm going to run out of room. Well, and that's minus mu sub 1 minus mu sub 2. And that is over the square root of variance sub 1 over n sub 1 plus variance sub 2 over n sub 2. Now, we can eliminate this part of the equation, the mu sub 1 minus mu sub 2, because H naught states the mu sub 1 equals mu sub 2, so that would be 0. We don't need to subtract 0 from anything at this point. So x bar sub 1 minus x bar sub 2, so 260 minus 269. Over variance sub 1, so that's 53 squared over 35 plus 34 squared over 35, and we need to square root of that before we divide. So you got negative 9 over all this. Put it in the calculator. Be very careful of your syntax. Good luck. I don't think you even need those parentheses, but I felt like drawing them in there. Anyway. So we will do that gives us a critical value of gives us our test statistic. T is negative 0.8456. Now, there's a way to do that in the calculator if you don't want to do all this, which you probably don't, but I suggest do both ways to check your answer. And if you will go into the calculator under stat tests, it is 2 sample t-test. Yep. 2 sample t-test. It's going to ask you for all this business. Put it in, calculate, make sure you do it for stats, not data. And it's going to give you a p-value as well. Of 0.4013. So we can already see that the p-value is greater than the alpha. We don't know anything about the test statistic t yet because we haven't found the critical value or the critical values. Since it's not equal to, it's going to be a two-tailed test. So to find the critical value, you're going to go in your t-table. T-table and degrees of freedom is n-1, so it's going to be 34 on the left column, and you're going to go under alpha is 0.05, but that's needs to be split in half because it's two-tailed, so 0.025 on top, 34, they meet at 2.032, and that is plus or minus. So, put it up here. Critical value plus or minus 2.032. Now we can draw our curve. Two-tailed test, artificial zero. We have 2.032 on this side, negative 2.032 on this side. Rejection regions. Test statistic, negative 0.8456. Probably falls somewhere about there. That is the test statistic. T naught equals negative 0.8456. So our decision we do not reject H naught. If it was out here, we would reject H naught. And there's not sufficient evidence to support the claim.